Hello guys, today we are going to see our general method. Means up to now we were looking a special method which were based upon our right hand side. That is, when our right hand side was exponential, trigonometric, polynomial, constant, either or product of them, means product of exponential, trigonometric, and these were our special cases. So, to solve our linear differential equation with higher order, we have got two process: special way, general way. We have completed our special way. Now we look our general way. That how it works. General method. This method is useful when shortcut or a special method is not applicable to find the complete solution of the given linear differential equation with higher order. We have learned that in a special way, just only sine and cos term is needed in the right hand side. But what happens if there is cosec, tan, sec, cot? In this step, our special method going to fail. Means whenever there is other trigonometrical form rather than the linear sine and cos, our special method or shortcut method going to fail. So we will apply their general method, in which we have got some steps. A step to solve by general method. We have got same way to find CF, means up to complementary function. We have got the same process to solve. Then after it is going to just differ in PI case, where PI equal to right hand side divided by symbolic form, that is auxiliary equation symbolic form of D. Here we will use some formula, so it's only going to differ in our PI cases where we will use some formula. So in PI, right hand side divided by symbolic form, that is function of x divided by function of d. Here function of d must be resolved into product form. The symbolic form, that is function of d, must be in product form. Okay, then after, if it is product, then we are going to use some formula, 1 by d plus m, function of x equal to e to the power minus mx integration e to the power mx and function of x dx. Means suppose here in bracket there is plus, then we are going to use here minus, then we are going to use here plus. Here is plus, then opposite minus, minus opposite plus, like this way. Suppose in the same way, if there is d minus m into function of x, then it become e to the power mx integration e to the power minus mx function of x into dx. That is how here is minus, then its opposite plus, plus opposite minus. Means conclusion, we can see that suppose here is d plus 2, then plus going to be opposite minus, and we written here minus 2, then minus 2 going to be opposite, it going to be plus in this format, and this is function of x copied as function of x into dx. If there is plus, then we're going to use minus. If there is minus, then we're going to use plus. And here we written minus, then here it will be plus. If here is plus, then here it will be minus. In our general method, that steps are: first we should convert our given differential equation into symbolic form. Then we will further move ahead for auxiliary equation, from where we will going to get value of roots, that is d, and according to which we are going to write our complementary function. Up to here all the processes are same up to CF. In PI, function of x divided by function of d, that is right hand side divided by function of d, which is from auxiliary equation, that is function of d, and that function of d must be in product form. Thereafter we should use the formula which we have discussed already, this one formula. But here we got two cases on the basis of function of x, that is 1 and 2. Suppose if function of x is in the form of e to the power x, if function of x is not in the form of e to the power x, that is only x, then we got two different way from here, like this. Suppose function of x in the form of e to the power x, and function of x is not in the form of e to the power x. If there is a function of e to the power x, then we are going to follow one formula only, But if it is not in the form of e to the power x, then first we have to convert our denominator, that is function of d, in partial fraction. Means if it is not in e to the power x, then we are going to use partial fraction of function of d. Then after we will use this formula, which is common in both. Then after we will going to use Euler formula, which is given by this. Means e to the power ix equal to cos ax plus I sin ax. Suppose if there is minus e to the power minus ax, then we are going to use cos ax minus I sin ax. If there is function of e to the power x, then we are going to use just only one formula this. But if there is not function of e to the power x, then we are going to use these three steps. And in this general method, we are going to need some formula of derivative and antiderivative. And we know if cos x is derivative of sine, then sine x will be antiderivative of cos x. Like this, derivative of sine x is cos x, so antiderivative of cos x is sine x. Just is going to be reversed. So means whatever we got the derivative value, that is sine cos sec square, sec into tan, cosec square, cosec into cot. Just we will integrate this, we will go into this our answer. Means here derivative of cos is minus sine, so antiderivative of sine is minus cos. That minus sign can be used either on side. Similarly, derivative of tan is sec square, so antiderivative of sec square is tan x. Similarly, derivative of sec x is equal to sec x into tan x, so antiderivative of sec x tan x is equal to sec x. Same way, derivative of cot x minus cosec square x, so antiderivative of cosec square x is equal to minus cot x. The minus sign can be used on either here or here. So derivative of cosec x is equal to minus cosec x into cot x. So if we integrate this side, means antiderivative of cosec x into cot x equal to cosec x. Means whatever we got the value of derivative, if we integrate them, we are going to get the value of antiderivative. Means if we integrate this side, we are going to value of this side. But what happens if this occur? Means tan, cot, sec, cosec. I mean to say that these four terms are not appearing alone on this side, on this value of derivative. Means there is no tan, there is no cot in separate, not in multiplied like this and this. There is no cosec. Here is cosec square, but we are going to need cosec. There is no sec. Here is in sec square, but we are going to need sec. So there are some special like this: tan, cot, sec, cosec, and you have to learn this formula so that we can solve our equation easily. That is, antiderivative of tan x is equal to log sec x or minus log cos x. Similarly, antiderivative of cot x equal to log sin x or minus log cosec x. Similarly, antiderivative of sec x is equal to log sec x plus tan x or minus log sec x minus tan x. And final, antiderivative of cosec is equal to log cosec minus cot or minus log cosec plus cot. So you have to learn this formula. And in antiderivative, if there is x plus minus b instead of x, then divided by the coefficient of x, that is a. Example, we can see sine has an angle in the form of x plus minus b. So we know antiderivative of sine is minus cos, and the angle is copied as usual. But whatever there is coefficient of x, we should divide by that coefficient of x, which is a. So you have to focus that if there is x plus minus b instead of x, then we have to divide with the coefficient of x, that is a. So just this is our some formula which we are going to need in coming topics.